We're going to continue our discussion about absolute value by looking at models of absolute value. So in order to model an absolute value equation, you first want to sketch a number line and then you're going to draw an arrow. We always want to start our model at 0. So for this first example, we want to model the absolute value of negative 3 equals 3. So we're going to draw an arrow starting at 0 that stops at negative 3. So if we start at 0, to get to negative 3 we need to go to the left. So I'm going to draw an arrow that faces to the left, and then I'm going to draw bars around my arrow to show that I'm looking for that absolute value. So it just kind of reminds me of those absolute value bars that we're writing around the number. We're also going to put it around the arrow. Since this arrow is facing to the left, it's showing us the model for the absolute value of negative 3. If we had started at 0 and drawn an arrow to the right 3 units, this would be showing a model for the absolute value of 3. So that's just something to consider. If you look, how many spaces long is the arrow? If you count the units, we have 1, 2, 3 units, so it's 3 long. And this tells us that the length of the arrow is the absolute value of the number you want to find. So we were trying to model the absolute value of negative 3. We know that that answer is 3, but our model shows that it's 3 units from 0, so that's true. This just kind of brings back our definition for absolute value, which is the distance a number is from 0. This is just how we can model that. I want you to pause the video and try the following 4 examples. Once you do that, you may press play and then check your work. Go ahead and reference that example that we just did together in case you get stuck. So now that you've tried these, let's talk about how to go through or how to model these, and I want you to check your work and make any changes if you need to. So in this first one, we're modeling the absolute value of 4 equals 4. We're always going to start our model at 0, and in this case we're going to 4, which is to the right, so this time our arrow is facing to the right. We're going to add our bars, and now this is showing that the absolute value of 4 is 4 units long, so it's equal to 4. Moving on to our next example, we're finding the absolute value of negative 1 equals 1. So again, start at 0, go to negative 1. So our arrow is facing to the left this time because we have a negative number inside our absolute value bars. We add our bars around our arrow, and now we have a model for the absolute value of negative 1 is 1 length long, or 1 unit long, so it's equal to 1. And the next two, this one shows the absolute value of negative 1/2 equals 1/2. So we're going to have to mark where negative 1/2 would be on our number line because it's not there for us. So that's going to be between 0 and negative 1, about halfway between there. So negative 1/2 is there. We start our arrow at 0. Stop at negative 1/2, and we add the bars around our arrow. This arrow is only half a unit long, so the absolute value of negative 1/2 is just equal to 1/2. In our last example, we're finding the absolute value of 2.5 equals 2.5. So we're going to mark 2.5 on our number line again. So this is 2.5. Go back, start your model at 0. Move to the right this time for the positive number inside our absolute value bars. Draw your bars around your arrow. The length of our arrow is 2.5 units, so the absolute value of 2.5 equals 2.5. I want you to pause the video again and try to match each of the following models with the correct equation over here. Your letter C is a little bit different because I made a mistake in your notes, so if you want to go ahead and change C and then pause the video to begin your work, you may. So now that you've tried this on your own, let's talk about the correct answers. So in this first model, we're starting at 0, and we have an arrow that faces to the left. That's going to tell us that we're going to see a negative number inside our absolute value bars. So our model goes until negative 10, so we're finding the absolute value of negative 10. We know that this arrow is 10 units long, so that's showing this third option here, C, the absolute value of negative 10 equals 10. In our next model, we're starting at 0 and we're moving to the right, stopping at 15. So this arrow is 15 units long, and it's showing the absolute value of 15 equals 15. So since it was facing to the right, we're looking for that positive number inside our bars, so B is the best choice for this. In our last model, we start at 0, and this time our arrow moves to the left, so we'll know we'll be looking for a negative number inside our bars. and we stop at negative 15, so the absolute value of negative 15 is 15. That's how long our arrow is. So A is the best choice for this third model. As we move into these last two examples, they're a little bit different than what we've been seeing. So in this first one it says, choose the best answer. The absolute value of 3 is equivalent to the distance between. So we first want to consider the absolute value of 3. We know that that's equal to 3. We're saying the absolute value of 3 is equivalent to, which just means it's equal to, the distance between. And then we have three different options to look at. So if you consider option A, they're saying that the distance between 1 and 2 should be equivalent to 3. But if we look down at our number line here, 1 and 2 are only 1 unit away from each other. So that's not the 3 that we're looking for. So A is not the best choice here. If we move on to option B, it's saying that the distance between negative 3 and 3 should be 3 units apart. If we start at negative 3 and count to 3, 1, 2, 3, 4, 5, that's 6 units away. So that's too big. That's not how far our absolute value is that we're looking for. We're just looking for 3. So B isn't a good choice either. In option C, it's saying that the distance between 5 and 8. So if we start at 5 and we go to 8, that's 1, 2, 3 spaces away from each other. And that looks true. So this is going to be read finally as the absolute value of 3 is equivalent to the distance between 5 and 8, which we know is 3 units, and that makes sense because we are looking for the absolute value of 3, which is equal to 3. So go ahead and try this problem on your own. It's very similar to the one we just did together. Pause the video and check your answer when you're done. So now that you've tried it on your own, let's talk about which one is the correct answer. The absolute value of negative 6, so we'll start by writing that down, is equivalent to the distance between which one of these options. Well, we know that the absolute value of negative 6 should be 6. So we're looking for two numbers that are 6 units away from each other. So between 4 and 9 is our first choice here. So if we count from 4 and go to 9, that's only going to give us 5 spaces. So it's close, but not quite 6, and that's what we're looking for. So A is not the best choice. Option B, it's telling us to start at negative 5 and count to 7. If we count all of those loops from negative 5 all the way up to 7, that's actually going to give us 12 whole units, and that's way too much. That's not what we're looking for here. So B isn't a great choice either. Option C, if we start at negative 4 and we go to 2, counting up all of those, that's exactly 6 units. And we were looking for the absolute value of negative 6 equals 6, so 6 units away from each other. So that distance between negative 4 and 2 is equivalent to the absolute value of negative 6, and C is going to be our best choice here.